Okay, let's have a look at factorising, expanding and simplifying algebraic expressions. So an expression, remember, is a gathering of terms that does not contain an equal sign. A term is something like 6a or 5z. An expression is something like 6a minus 5z. But there's no equal sign, it is not an equation. So let's look at the first one here. The instruction is to expand, and we've got this expression here. So the 3 is a multiplier, and it affects both terms inside the bracket, and that's what I've shown with the orange arrows. And so in turn, the 3 multiplies by the 2a to give us 6a, and by the minus 4 to give us minus 12. In the second question then, we have a similar situation, but we've got 2 sets of brackets, and we would treat them separately and then gather together anything that we can see that is alike. So the minus 2 in the second bracket here, or sorry, outside the second bracket, must affect both terms in the second bracket. So it's important that when you are doing something like this, that the minus goes with the 2. It belongs to it and it must travel with it. So let's look at this first bracket first. We've got 3 brackets, c minus 1 close bracket. So that is 3 times c, which is 3c, and 3 times minus 1, which is minus 3. So that's where those first 2 terms come from. Then look at the second bracket, remembering that the minus belongs to the 2. So we have minus 2 times c, which is minus 2c. And we have minus 2 times 4, which is minus 8. So all those 4 terms have come from multiplying out those brackets there. And what we should do then is to gather together anything that's alike. And what I've done to show that more easily is I've circled in orange the terms that contain c, and I've put a square around the ordinary numbers. And you should include the signs, just makes life easier. So if you look at the 2 things in orange circles, we have 3c minus 2c, which just gives us c. And the numbers in the squares are minus 3 and then minus another 8. So altogether, that's minus 11. Let's have a look at the third one. Okay, so this time instead of saying expand, the instruction is to solve. And it says solve 3 bracket 4d plus 1 close bracket equals 21. So this is an equation. And the word solve tells us that we are looking for a value, a number, for the variable d. So the first thing to do here is to expand the brackets because it makes life easier. And so just as we did in the previous 2 questions, the 3 multiplies by the 4d to give us 12d, and the 3 multiplies by the 1 to give us 3, and equals 21 stays the same. And then there are a couple of things we need to do to get to having d on its own, which is what we want. So if we take that 3 away from both sides, then we have 12d equals 21 take 3 is 18. If we then divide by 6, we have 12 divided by 6 is 2, 18 divided by 6 is 3. And then the last thing to do, this 2 here is a multiplier, so we divide by 2 to get rid of it, which gives us d is 3 over 2, or 3 divided by 2. Okay. Number 4 then. Simplify. So we've seen expand and we've seen solve, now we're looking at simplify. And what we've got is this term here, which is a cubed b squared, and we've got this term here which is 4ab to the 5, and the instruction in the middle is to multiply. Now when you're multiplying, you can separate out the terms and then gather them together, and I think sometimes that makes it a whole lot easier to see. So on the next row down, I've separated out a cubed b squared to say a cubed times b squared, and I've also separated out the next one, which is 4 times a times b to the 5. So what you can see there is a whole string of multiplications, and when we have a string of multiplications, it does not matter the order in which they're done, and we call that commutative. You don't need to remember that, but that's what it's called. It means the order doesn't matter. And so you can swap them around, and I can say, well, that's got an a in it, and so has that. So if I times that a cubed by that a, I end up with a to the 4. That's tidied that bit up. And if I do the same with the b's, I've got b squared times b to the 5, which is b to the 7. And then this 4 is just a number, so it stays the same. And then I've simply reversed the separating out by putting them all back together again. And usually, when we write things like this, the number comes first, and then any letters that are involved go alphabetically. So we end up with 4a to the 4, b to the 7. Right, number 5, let's have a look at that. Factorise. Now factorise is the opposite of expand, and when we factorise things, we are looking for common factors in both numbers and letters, if they exist. If they don't, then we can't find them. In this case, we've got y happening in both terms, but the numbers 1 and 7, there's no relationship between those, so there's no common numbers here. So let's take the y outside a bracket, the y that we've said is common, and see what effect that has. In other words, what we've got left in the brackets here, if we were to multiply it out, it should give us what we started with. And so hopefully you can see that y times y is y squared, and y times 7 is 7y. So what we're looking for when we factorise are common factors or common elements. We take those outside a bracket, set up a set of brackets, and then decide what's left when that factor has been removed. Okay, one last one then. Let's look at number 6. Now this one says factorise fully, which might sound a bit scary or a bit more detailed or a bit more complex than number 5. But all it means is be careful and look out and make sure that you have got the common elements, all of them, in the right place. So let's have a look. Are there any common numbers? Well, we've got a 1 here and an 8 there, so no, nothing we can divide or factorise. Is A common? No, it only appears in this term. But B, because it appears in both, is a common factor, and so we can take that outside a bracket and then have a look and see what's left. So b squared comes from b times b, and 8ab comes from 8a times b, or should I say minus 8ab comes from b times minus 8a. So you can see from that if you were to reverse the process, you would get back to this original expression.